Agartha needs you to derive the equation of a circle with radius r centered at AB to re-enable Agartha's force field.
Bro, where do I even start with this
My son, let's start off with an easier problem first. How would you describe a circle?
I don't know, a round thing?
What do all points on a circle have in common?
Oh, they're all the same distance from the center of the circle?
Exactly, my son. A circle is a collection of points at a certain distance, aka the radius, from the center.
How does this help me get an equation for a circle?
How do you calculate distance when you know the horizontal and vertical offset?
You make a right-angled triangle and use Pythagoras.
Precisely, my son. What relation between x and y would give a circle centered at the origin?
We use Pythag on the distance from the origin to xy to get x squared plus y squared equals the radius squared.
Correct, my son. Now, how would you change the center of the circle?
Would you add the coordinates of the center to x and y?
No, my son. You need to subtract them. Think of it like this. The value for x and y have to be higher to reach the same value as without subtracting.
Oh, and adding will move it left or down. Weird, but it makes sense, I guess.
Well done, my son. Those 600 years of selective spawning were worth it just for you. Agartha needs you to derive the quadratic formula to educate the goylings.
Bro, how am I even supposed to start this?
Well, you can start off by dividing everything by a.
What if I visualize this in terms of shapes? A square with area x squared plus a b over a by x rectangle plus a shape with area c over a.
My son, it doesn't make much sense for the areas to add to zero.
Good point, bruh. I'll have to move this one to the other side of the equation.
Now, my son, if you split the b over ax in half, you have a square with the corner missing.
Oh, so we can complete the square here.
That's right, my son. You can do this by adding a square with side length b over 2a.
So now we have this equation. Let's add these fractions together.
Now to undo the squared bracket, we have to square root both sides. Don't forget the plus or minus though.
And then we bring this term over to the right-hand side. Then we have the quadratic formula.
Grand work, my son. You are my finest creation. Agartha needs you to solve this quadratic equation to enable the cloaking device so the T-50s don't find us.
This is easy as bruh. Just plug it into the quadratic formula.
Go ahead, try it.
Wait, what the How am I supposed to take the square root of a negative number, bro?
There's this secret number in math called I, and if you square it, you get -1.
How is that even possible? Sounds like a psyop by the Jews.
Let me finish. It's not a real number. I is what's called an imaginary number.
Oh my god! Fake and gay.
It's actually useful, my child. What happens when you multiply a positive number by -1 on a number line?
It rotates 180 degrees to the other side?
That's right. So now imagine you have a new imaginary number line at a right angle with the real one.
Oh, I see. So multiplying by I is like a 90-degree rotation instead?
Exactly, my son. So now we know the principal square root of -1 is I. Let's finish solving that equation.
So we end up with the square root being equal to 14i?
So the final answer is 6 plus or minus 7i.
Wait, what did you say? 6! 7!
Agartha needs you to derive the power rule from first principles to top up our vril.
So I need to use the definition of the derivative and plug in f of x equals x to the n?
That's right, my son. Now, solve the limit.
I don't really get limits, though. Isn't this just 0 over 0 and therefore undefined?
Limits look at what value is being approached. The function doesn't necessarily have to be defined at that point for the limit to exist.
Well, aren't I kind of just stuck here? Because I don't know what n is, so I can't really expand by using FOIL.
You need to use the binomial theorem, my son.
Oh, so now the x to the n's cancel out, and now everything is a multiple of h, so we can divide by h?
Since h tends to 0, we can treat h as if it was equal to 0 now.
So the result is n x to the n minus 1?
Marvelous work! Yet again, my child. Agartha needs you to differentiate the natural log of x from first principles to restore glory to the Aryan race.
What in earth are you talking about? How do I even start with this, bruh?
My son, recall the properties of logarithms. Remember this index law?
Of course I remember this. It's basic.
Now let m and n be log base a of b and c respectively. Taking log base a on both sides gives this identity.
Oh, right, but Hold on, how does this help us?
Recall this definition of e. Since it exists, if we take the log, it can go inside the limit.
This looks familiar. If we do this, we can separate this part that equals 1, so we end up with the result 1 over x.
Magnificent work, my son. You make me so proud. Agartha needs you to derive Euler's formula in order to save the Aryan race. Good luck, my son.
Bro, what the How do exponentials work with imaginary numbers?
You need to use this power series for e to the z.
Where does this even come from, dog?
It's just the Taylor series of e to the z.
I see, and since you can differentiate e to the z forever and the result never changes, all orders of derivatives are just equal to 1.
Since I squared is -1, this means I cubed is -I, and I to the 4th is 1, and this goes forever in a loop.
So when substituting z equals ix into that Taylor series, we get this.
Now split this into its real and imaginary parts. What functions are these Taylor series of?
I don't know my Taylor series off by heart, bro.
Think of a function whose derivatives at x equals 0 have the pattern 1, then 0, then -1, then 0, repeat.
Cosine! And the next one goes 0, 1, 0, -1, repeat. So that must be sine, right?
So we have that e to the ix is equal to cosine x plus I sine x.
Marvelous work, my son. You are vrilling your race one gem at a time. Agartha needs you to solve this differential equation to increase the Aryan birth rate.
Gang, what even is this, bro? Where even are the numbers? I thought this was math, not English.
My child, what happened to you? Here, drink this.
Oh, I'm back. Thanks, Yakub.
If the partial of m with respect to y is equal to the partial of n with respect to x, the dE is exact.
Okay, and it looks like the dE is exact, so what now?
The solution will be of the form f of xy equals c, where the partials of f with respect to x and y respectively will be m and n.
Oh, I see. So we can integrate this with respect to x to get the answer?
Don't forget that since y is a constant with respect to x, we need to add a function of y as the integration constant.
Oh, but now we can take the partial of this with respect to y, and now we have an equation. Oh, look, it turns out g of y is 0 anyway.
Well done, my son. You have made Agartha proud. Agartha needs you to solve the Gaussian integral to give the goyim on the surface more vril. Good luck, my son.
Bro, not this useless integral. I was up all night trying to solve this.
Here's a hint, my son. Square the integral and change it into a double integral.
Wait, x squared plus y squared, this means we can use polar coordinates. All right, so we need to multiply the new integrand by the Jacobian, right?
Whoa, I think you mean the Jacobian.
My bad, Yakub. How could I forget? Multivariable calculus was your third greatest invention after the white race and jelking.
Now we can do a u substitution. Therefore, the result of the integral squared is pi.
Since the graph is always above the x-axis, we know the integral is the positive square root of this. Therefore, the answer is the square root of pi.
Nice work, Steparian. I've got a reward for you now, Teehee.
Agartha needs your help. You must solve this integral to reactivate Agartha's force field. Good luck, my child.
Bro, what the am I meant to do with this? I thought sine x over x had no elementary antiderivative.
But there is still a way to get a value for this improper integral.
Ah, I see. We basically define a function that is equal to our integral at a certain point to turn it into an initial value problem.
Using Feynman's trick, we can differentiate under the integral sign.
So now we can just use integration by parts here?
It's quicker to do the Laplace transform of sine.
Oh yeah, so it'll be -1 over 1 plus t squared. Now what though? We need a value for c?
All we gotta do now is compare the limits as t approaches infinity of both expressions of I of t, yielding this simple equation.
Alright, so we have the specific solution to the initial value problem. Now we just need to sub in 0.
Marvelous work, my son! You have resheathed Agartha's defenses! You have saved your race! Agartha needs you to solve this integral to stop the Israeli invasion of Agartha. Good luck, my son!
No bet, twin! So do I just do a u substitution here, or?
No, my son. You can use integration by parts, so you don't have to deal with integrating arctan.
Oh, right. We set u to the integrand and dv to dx, then we find du and v.
Notice that whether this limit goes to infinity or 0 here, either way it equals 0, so we can discard this term.
Good, bruh. This integrand is way easier to deal with. Still got no clue what to do, though.
My son, here you can factor the quartic into 2 quadratic factors, but beware, it has no real roots.
If I find all the complex roots, though, I can multiply the conjugate linear factors to get 2 quadratic factors.
Obviously, x squared is -1 plus or minus 2i, but what complex number squared equals this one.
Let's do -1 minus 2i first. Expanding gives us this system of equations.
Since b is the negative of the reciprocal of a, substitution reveals this familiar equation.
Wait, this gives golden ratio vibes, twin.
The reciprocal of the golden ratio, to be precise, my son. So a itself will be plus or minus 1 over the square root of 5.
And b will be minus or plus the square root of 5, so these are the square roots of -1 minus 2i.
For -1 plus 2i, it's a similar story, except b is the positive reciprocal of a this time round.
So for this one's square roots, the real and imaginary parts have the same sign.
Multiply the conjugate linear factors, as this is a difference of squares, and thus any mention of I is removed.
I flow, Kirk, taper, fade, literal, and Ewingly don't want to deal with this holy yap for the rest of the integral, so let's tidy TS up.
The sum of the golden ratio with its reciprocal is the square root of 5, my son.
Ugh, now we have all this partial fraction to do, though.
We know that f of negative x is equal to f of x, so it follows that c equals negative a and d equals b.
Now, if we multiply the equation by the quartic and expand the products, looks intimidating, but a bunch of cancels out. Since the constant term is 0, b is 0, and 4a over radical phi equals 4, so a equals radical phi.
Now, since we have a linear divided by a quadratic, let's try to get an integral of the form du over u.
If we let u equal the denominator, taking the derivative yields this, so let's try to turn the numerator into this.
So we multiply and divide by 2 to not change the value, and also add and subtract this, then combine the integrals.
So the antiderivative ends up being a difference of logs that we can combine into a log of a quotient.
That's right, my son. Let's simplify this quotient to make the numerator a lower degree than the denominator.
Now, since ln of 1 minus this function is continuous, we can turn this into ln of 1 minus the limit.
You got it! And the limit to infinity where the denominator has a higher degree will always be 0.
So we did all that just to get 0. Are we dead?
Now we can just pull the numerator out and change the lower bound of the integral to simplify.
Oh, and now we can cancel out these coefficients and then use the arctan integral rule to integrate these.
Then plugging in the bounds gives us this, and notice that since arctan is an odd function, these terms will cancel.
And this limit is the well-known result pi over 2, then we multiply and get the result pi over the square root of 5.